For more problems and videos like this for linear algebra, you can take a look at Sarai Studies, link is in the description box below. In this video, we're going to talk about the conditions that a matrix needs to satisfy in order for it to be in row echelon form. So the first one is that all 0 rows are at the bottom of the matrix. So remember that 0 rows are just rows in a matrix that are all zeros. The second one is that the leading entry in a row must be to the right of the leading entry in the row above it. If that doesn't make sense to you, that's okay. It didn't to me when I first heard of it, but it makes more sense when I visually show you an example in a second. But recall that a leading entry is just the first non-zero entry in a row. In other words, for every row, it's the first number you see that's not 0. In this case, this is the first number I see that is not 0, so 1 is the leading entry for row 1. And then for row 2, this is the first number I see that's not 0, so that's the leading entry for row 2. And finally, the last condition is that the entries under the leading entries are equal to 0. To get a matrix to satisfy these conditions, we call performing those steps row reduction or Gauss elimination. Now let's practice finding out if a matrix is in row echelon form. We're going to see if it satisfies conditions A, B, and C. So the first one is that all 0 rows are at the bottom of the matrix. This here is a 0 row. Is it at the bottom of the matrix? Yes, so condition A is satisfied. The second condition is that the leading entry, so without even reading anything, identify your leading entries. Your leading entries are the first number that's not 0 you see in each row. So here, this is my first leading entry. So this is my leading entry in this row. Here I go, skip wherever I see 0. The first time I see a number that's not 0, that's my leading entry. And here I go, they're all 0, so there's no leading entry for this row. So it's saying the leading entry in a row must be to the right of the leading entry in the row above it. So for this one, you ask yourself, is this leading entry to the right of the leading entry in the row above it? Well, it doesn't have a leading entry in the row above it, so this one's fine. You move on to the next. Then you ask yourself, is this leading entry to the right of the leading entry in the row above it? Which is the leading entry in the row above it? This one. Is it to the right? Yes. Is it also below it? Yes. Because saying that it's to the right of the one above it means that this one should be below this one. So this condition is also satisfied. And finally, the entries under the leading entries are equal to 0. So this is the leading entry. Are all of the entries under it equal to 0? Yes. This is the leading entry. Are all of the entries under it equal to 0? Yes. Condition C is satisfied, and therefore, this matrix is in row echelon form. Now let's try another one. Now you see that I have ZSO. What does that mean? Well, that's like my little mnemonic to remember the conditions for row echelon form. So instead of ABC, I'm just going to do ZSO, where this is really a 0. So I read it as ZO. So Z for all 0 rows need to be at the bottom of the matrix. S, that the matrix needs to satisfy the staircase hack. And if it passes the staircase hack, then that means that this is true. So condition B is going to be satisfied, and I'll show you what that means in a second. And then this O, which is really a 0, is that all of the entries under the leading entries are equal to 0. So it's a nice way to remember these conditions here. So let's start. The first one, are all 0 rows in the matrix in the bottom of the matrix? Well, there aren't any 0 rows, so this is irrelevant. It's not applicable, so it passes. Then does it pass the staircase hack? You need to identify your leading entry. So again, for each row, I go until I see my first non-zero number. That's this one. For each row, I go until I see my first non-zero number. That's this one. Each row, I go until I see my first non-zero number. That's this one. So these are my leading entries. And then you want to start with the first leading entry that you see, and then you go, and then go down anytime you see another leading entry. Go down anytime you see a leading entry. And then if these are just 1, so 1, 1, then therefore it passes the staircase hack. But ideally what this means, it proves that every leading entry in a row must be to the right of the leading entry in the row above it. And we can check. Is this leading entry to the right? The leading entry in the row above it? Yes. Is this leading entry to the right of the leading entry in the row above it? Yes. And then this one is not applicable because there is no leading entry above it. So instead of checking each one, you can just do the staircase hack. And I'll show you in another problem what it looks like when we don't pass the staircase hack. But before that, let's check this one. All entries under the leading entries have to be 0. Are they? Yes, yes. This is a leading entry. Are all of the entries below it 0? Yes. This is a leading entry. Are all of the entries below it 0? Yes. This is a leading entry. There's no entries below it, so it's unapplicable. So this does pass this third condition, and therefore this matrix is in row echelon form. Let me highlight the zeros here too. Now for this one, are all 0 rows at the bottom of the matrix? Well, here I see a 0 row. It's not at the bottom of the matrix, so therefore it does not pass this condition. So I already know that this is not in row echelon form. But let's check the other conditions so you can see if they pass or not. So to satisfy this condition, we can do the staircase hack. Again, you need to identify your leading entries before you do that. So the first non-zero entry you see in a row, here there's no leading entries because they're all 0. Here you go until you see the first non-zero number. That's this one. Then for the staircase, you start with your leading entry. You go, and only go down once you see your other leading entry. But does this look like a staircase to you? If you are right here and then you step off, honey, you're gonna die. There's nothing here. You're gonna fall. So it doesn't pass a staircase hack either. What about this one? Are all entries below the leading entry zeros? Well, here, this is a leading entry. Are all of the entries below it 0? Yes. This is a leading entry, there's no entries below it, so unapplicable. So it does pass this condition. But because it doesn't pass either of these, it has to pass all of them for it to be in row echelon form. So it's not in row echelon form. And finally, let's look at this one. Are all 0 rows at the bottom of the matrix? There aren't any 0 rows, so that's unapplicable, so it automatically passes. Does it pass a staircase hack? Again, identify your leading entries. So you start at the first row. Oh, this is the first number that I see that's not 0. I highlight it. Start at the second row. Oh, this is the first number I see that's not 0. I highlight it. Then you go on your third row. Oh, this is the first number I see that's not 0. I highlight it. So I start with my first leading entry, go until I see my next leading entry, and then I just keep going because there's still a leading entry, and that's a problem because it has 2 in height. We only want 1 in height. Do you know why? Because if you are right here and you take a step, honey, you're gonna die. This is too steep of a staircase. We can only take a step like this. Similarly, if you have a staircase that looks like this and you're right here and you take a step, you are going to die. That's why we don't like these long staircases. We only like a height of 1, nothing more than 1. This is like 4 in height and this is 2. So the idea is, because I see 2, this does not pass a staircase. So this one, it did not pass a staircase because it literally did not look like a staircase at all. And this one, it did not pass a staircase because we have a height of 2 instead of 1 for each leading entry. Let's see if it passes this one. Again, this is just asking, are all of the entries under the leading entries 0? Well, let's check. This is a leading entry. Are all of the entries under it 0? Yes. This is a leading entry. Are all of the entries under it 0? No. So therefore, it does not pass this one. So this matrix here is not in row echelon form. So remember, use ZO to recall the conditions that you have to satisfy in order for the matrix to be in row echelon form. And in the next video, we'll go over reduced row echelon form. So I'll see you then.